What if my printer could make electronics? Researchers in nanoscience at UNL say it can. Find out how by scientists in the field.
Our research, we are using a simple inkjet printer, the same inkjet printer that you would have in your home, a $90, $100 printer that you can buy at Walmart. We're loading up empty ink cartridges with organic molecules that previously have been shown to exhibit ferroelectric properties, can essentially conduct electricity. We are loading up these ink cartridges with these molecules and then printing them out onto different surfaces like gold or platinum or silicon substrates, so then hopefully to create new ferroelectric materials.
So, how does it all work?
For Nick needs to print any gluconic acid or 3-HPLN, we'll go up to the lab and mix the solution together and then put it in an empty print cartridge.
The cartridge with like a solution. So these are the solvents, and then these are the materials we're looking at. And so we just fill it with the solution, and then it actually works really well. You can just print right from it. Printing, we have these patterns, just little CD cutouts of paper up where we put the substrates, and then we print on top of those, just to see what the chemicals do. So if we print lines and it kind of looks solid, then we know that means it probably spread out and stuff.
Printing in action. What's the future with printing ferroelectric materials?
So we would like to develop organic materials so that they can be useful for electronics applications. Electronics right now is being fabricated using silicon as a semiconductor material in one of these silicon pieces I have right here, and it is a very brittle, very hard material, and it takes a massive infrastructure to actually make these materials. But organics are in many ways electronically just like those semiconductors. They have many of the similar properties, but they also have many advantages. They can be made much more cheaply and they can be printed on surfaces, which is exactly what we are trying to do in our lab. And once they are printed on surfaces, these surfaces can be flexible like this sheet of paper, and we can just bend them and then squish them and do something to it. So we could imagine in principle that we print electronic circuits on t-shirts or on newspapers to do something with it that cannot be done with traditional semiconductors such as silicon. And that is the goal of our research.
Now that's nano at the University of Nebraska at Lincoln.